Welcome back.
Good to be back, Andy.
It is good to be back.
Yes.
Okay, so we've seen a lot of content. There was a great session from Rob there on the enterprise story. Now I'm going to talk about the topic of developing apps from a single code base for Windows Phone 8 and Windows 8. So obviously a lot of debate about this. Is clearly we all want to have the benefit of creating apps for both platforms with a minimum of having to write platforms dependent code.
Absolutely.
So I'm going to take you through the story, point out where we've got commonality and where we've got differences, and show you some good techniques for how you can handle those differences. So there's three kind of areas in this particular topic. First of all, we're going to look at building for Windows devices. So we're going to focus on getting developers to think about the application you're building and considering the common elements such as tiles, notifications, use of grids and content rather than Chrome, the design language, but also how to respect the differences such as grid views and list views versus list pickers and long list selectors. And we'll have a look at the different screen sizes and have a look at the impact that has. Now, we're going to talk about a section on minimizing development. This is all about how you can reuse code. What code is reusable, what bits are not, and then for the bits where we've got sort of subtle differences, what are some of the techniques to share code where it's common and be able to incorporate platform-specific code where we need to. And then there's the architecture of the application. So there are a number of things you can do to architect your app that's going to encourage the most reuse, typically MVVM and patterns like that. So we're going to look at what that really means for you in developing apps that are going to run on both platforms. Unfortunately, no, we're not going to be able to cover too much about building apps that incorporate Windows Phone 7 as well into this pattern. So I'm sure you've realized already that actually anything you develop for Windows Phone 7 runs on Windows Phone 8 anyway. And there are a lot of the techniques for code sharing, like add as link and that sort of thing, apply just as well to having a single code base for a Windows Phone 7 version of your app, and then a Windows Phone 8 where you're adding additional capabilities using some of the new APIs that we've covered over these 2 days. But in the interest of, we're in trying to keep this focused and not trying to be too broad a brush here, we're going to focus on the Windows Phone 8 and the Windows 8 story. So, okay, the first of these three sections. First of all, the goal we all want is not to have to think about I'm building for Windows 8 or I'm building for Windows Phone. We just want to build for any Windows devices. This is what we want. So we're going to look for the consistency from a design perspective, as well as the differences in terms of the controls we're working with, the layout that we have to embrace, and the app life cycle. Now, one thing that is common across both platforms is the design language. The goal with both of them is to build apps with an awesome user experience. Windows 8 has adopted the same key design principles that are used in Windows Phone. So these principles were, Windows Phone 7 was the first big product that really brought these out. But even that was in itself a development of ideas that were developed in the Zune music player before that and Xbox. And so this work is not a new thing. It's been developed over a number of years. But we've ended up with these design principles, and we kind of almost started yesterday. After the introductory session, we sort of started with this. So it's kind of good now at the end of coming to the end of the second day, where we kind of revisit those design principles. And whereas you might sort of dismiss them as kind of marketing stuff, it's very important to keep these in mind as you're considering the design of your applications. All this pride in craftsmanship. The principle to remind developers that designers that you need to respect the grid and balance symmetry and hierarchy, and keep possible lines to the grid and build an intuitive user interface where the user is free to explore without fear that they'll accidentally break or delete something. And about being fast and fluid, because life is mobile, And with the continually increase in device capabilities, it's possible to bring a new dimension to applications in the form of animations, and this nice buttery smooth animation you keep hearing about. And Windows has a number of predefined animations that can assist with consistency, and you'll see these same kind of turnstile animations, the same kind of behaviors on a Windows 8 application as you'll see on Windows Phone 8. and being authentically digital. So both platforms, Windows 8 and Windows Phone, they share this design approach of using bold block colors and a relatively flat style. And this is a focus on allowing your application to breathe and not cramming too much information onto a single page. It's embracing the kind of clear space between stuff. There should be no attempt at skeuomorphism, to make applications mimic objects in the real world. These are digital devices, and we're celebrating the great fonts and the nice good use of colors, the relatively flat style. These are the key design principles in Windows 8 and Windows Phone. And it's about doing more with less. And this is about the content before Chrome. The key on this principle is to focus on the core objective. And too often this is not considered. And I said this yesterday. Whenever you're designing the structure of your application, keep asking yourself this question: why has the user opened my application? And be laser sharp in answering that question. The great stuff. Winners won. This is really all about embracing this shared heritage between this shared design approach between Windows 8 and Windows Phone. This unique design language that runs through the core applications on both platforms. You need to respect the design of the platform and, where possible, adopt the brand to complement this design language. You're giving users a consistent user experience which benefits the end user, you, the application developer, and device manufacturers, and of course Microsoft. The whole ecosystem. They're all part of that same family. Right, so there are some differences between the platforms, though. First of all, the screen size, for example. Okay, I mean, for Windows Phone, this isn't too much of an issue. As we've seen, we've got 3 different screen resolutions, but they are scaled automatically. So we are designing, as developers, to a logical pixel size of roughly 800 by 480. It's 856 by 480 on the 720p phones. So we've got those 3 resolutions, but they essentially are all pretty much the same aspect ratio. But for Windows, big Windows, you have to design interfaces that can accommodate different screen sizes and aspect ratios. So you have to do a little bit more work here. A lot of applications are being ported from iPad don't adapt well to Windows, as they've been designed for fixed proportions. We have to use controls such as the grid view or list view controls, which are essential to ensure that interfaces scale well. And orientation, Windows Phone, we have apps can optionally support portrait and landscape, but on Windows slates, tablets, applications must support this snapped mode. So this is a mode where the application sits in and at the left-hand sort of third of the screen. You don't have any choice, you must support that. And controls. So on Windows Phone, we're used to working with, we've got these unique page level controls, the panorama and pivot, which should be used when designing their application. There's also individual controls such as the long list selector, which is a replacement for the list box, and the list picker, which is Windows Phone's equivalent of the drop-down box. And these should be used to be consistent across your apps. Windows also, Windows 8 brings a number of unique controls. There's the grid view, which is this groupable tile array, and it's also possible to dynamically size items in the grid. And the grid view comes with built-in styles for input and selection. There's a list view, which is a replacement for list box for displaying lists of items on Windows 8. And semantic zoom allows to zoom in and out of a large collection, so you can easily navigate between a large collection. So that's kind of similar to the jump list style that we have on Windows Phone with the long list selector. And then on Windows 8 there's the flip view, which allows you to browse easily. It's optimized for touch to pane left and right through a lot of sequential items. And lastly, let's have a look at the differences in the life cycle. So the basic navigation model is very similar. So we're still working with pages and we're navigating between pages. So a lot of similarity there. Strong concept of navigating back on both as well. So we've got the hardware back button on the phone. Or on Windows 8 apps, you've always got a back button positioned on the upper app bar on Windows 8. However, there are still differences in the way applications are launched or resumed that you have to be aware of and must code for. So on Windows Phone applications, although this is changing with fast application resume, but by default, Phone 8 applications are always relaunched when the user starts an instance from the start screen or from the application menu. So you get a brand new instance. That's the default behavior. Sure, if you implement a fast application resume, then you can re-enable an existing dormant instance. But even with that, the default behavior of the project templates is to delete the page history. So it behaves exactly the same as starting a whole new instance. But Windows Phone applications can be tombstoned, but on Windows 8 there's no concept of tombstoning. Windows 8 applications can be suspended but never tombstoned. But both platforms support a variety of different ways of launching the app. So on Windows Phone, obviously it's a normal startup from the app menu, from tiles and from toasts, from speech, through App Connect, through search, through protocol associations, file associations, all these things that we've looked at over the last 2 days. And on Windows, we've got normal startup, again, toast and tile launch, search, share, and again, protocol and file association. So a good deal of similarities in there. Right, so just we've got an example here I'm going to show you, which is the sample application for this particular session. So this is a simple photo manager. So we've got in this solution, we've got a number of different projects where we've got a photo manager.win8, which is the UI, the presentation layer for a Windows 8 app. Photo manager.windows phone 8. We've got a project called photo manager.core. And we've got photo manager.shared. I'm going to be talking about what all this is. And actually both apps use SQLite. Now, I've said we haven't really got SQLite for C# apps on Windows Phone yet, but there is a third-party library that implements the same interface, but it's a pure in-memory, it's a pure C# database implementation of SQLite. But we're expecting to see better solutions coming along for Windows Phone 8 for C# in the future on that one. But we've still got a working solution in here. So a lot of shared, it's obviously the shared purpose. Let's run up the Windows 8 version first. Let's run this one. So I've got it running in the simulator here, and it's a photo manager. So I've got a selection of nice photos here.
Those
so
some nice-looking books.
They are beautiful, aren't they? Yeah.
Yeah.
So I particularly like the .NET applications for mobile devices. That was my first book.
Wow. 2002.
Awesome. Yeah. So yeah, and it is a classic. It is, yes.
Where do I get those mobile controls for the web page?
Leave it. This is my band in action. There we are, the rock face on me there.
Yeah, there it is, folks.
Yeah, there we go. So that's us in action. But you see, we've got this is the kind of style you're seeing here. We've got a nice menu to go through there. We've got a box here you can enter some comments there. We've got forward navigation and backward navigation. We've got we can select select one of these pictures like that. So it's clicked, and then
right click on it.
yeah, I'm trying to get it to work. There we go, and you can also, we've got the semantic zoom, so you can zoom out, and we can actually drill down into this is a way of navigating over a big collection, and you can navigate through here as well. These are different navigation styles, and we can grab it from the top. I'm trying to grab the bar. Here we go. Bit difficult on the mouse here. And we've got this snapped mode, so we can drop it into there. This is the snapped mode, and we could then start another application and drop that into. Let's have a look at the weather. There we go, and that gets dropped into there. So back home in Bangor, North Wales, near where I live, it's pretty cold. That's centigrade, by the way, in case you're watching this in the US. Yeah, that's about 40. And look, it's cloudy at the moment. And then you could drag this across. So now that one becomes the snapped, and this becomes the filled mode. So we've got different modes of different kind of layouts we have to support. And this is just one resolution, so we could try it on other different resolutions as well. So that's the Windows 8 one. The Windows Phone 8 version of that. Let's just get this guy up. Got running on here. So the photo manager, Windows Phone 8, here we go. And first of all, we've got albums on there. And we get nice use of the pivot, so we can navigate across like this. We can drill down into, there's no folders in the camera roll, so that's empty. But on the next one, you see all the pictures. So we can go and have a look. Oh, look, there's Rob. Hi, Rob. Yeah.
That's crazy.
Yeah. And the back button to go back again. And there's the band one. It also supports a landscape. So there you go. So automatically landscape and portrait. But other than that, that's the only sizes we need to support. But all of this is built from a lot of commonality. But I hope you've got the message there that actually the UI requirements to make the most of both platforms are really quite unique, quite specific. And just having we could have had the phone app running in a little letterbox on the tablet, but you're not making the most of the tablet there. That really is not what we want to achieve. Right. Okay. So now let's see about how we've built this particular kind of application. So a lot of shared code there, but you can see the differences in the user experience. So what about the strategies for sharing in a XAML app? How much of this code can we reuse, and how much do we have to code uniquely for each platform? We need to use a good architectural pattern. We're going to separate our UI layer from our underlying logic, and this is what we've done in this example. And there's a couple of approaches. There's a very useful technology called the Portable Class Library. And really, when you're building an application that is intended to work on both platforms, you should start almost building from the bottom up and build as much of your logic as you can in the Portable Class Library. Not all of the APIs are going to be supported by the subset of common APIs that are in the Portable Class Library. So you're going to have to use some device-specific code alongside that. But as much as possible, you want to put into a Portable Class Library. We can use the common Windows runtime APIs that are common across both platforms. Means that a lot of your code that accesses these sort of things, file and protocol association, is going to be the same. And then you need to complete that with platform-specific code as necessary. So it kind of looks a bit like this in general. This is a very high level. The user interface separation from your app logic. What that actually means in practice is we're using this model view model pattern. So the view becomes the user interface layer, and we use data binding to talk down to our classes of view models. We talked about this idea yesterday, and that also references down to underlying the physical data, the model down on at the bottom of the model there. So in the models, to drill down a bit more detail on that, you've got your data objects and some associated business logic associated with your data objects. The view models takes a kind of, well, the clue is in the word view. It's presenting views, so kind of similar. You could think of it in terms of a database view, in terms of a SQL Server kind of model. So you're presenting a kind of a molded presentation of the underlying data in such a way that the UI can easily data bind against it. And then above that, above your view models, you've got the actual views. So this is written in XAML, and the key message in here is that you don't have any application logic in your views. You can have logic in there that is just about doing stuff to present, to mold the presentation in some way. But none of your application logic, your data objects, must be in the views. And it uses data binding down to connect to the view model. So although the view has a reference, in fact, down to objects, properties on the view model, the view model is written in such a way it has no references to the view. It cannot call methods on the view. It doesn't have any awareness of the view. It's just an object that presents data out to and actions out to whoever it is who wants to consume it. And that whoever it is in this case is actually our views written in XAML. So those are going to be platform specific. This is where you're going to need one view for your Windows view layer for your Windows Phone app, and another view layer for your Windows 8 app. And as much as possible of the stuff underneath there, you're going to try and make that, put as much as possible into portable class libraries, and you're going to have to augment that with a few add-ons. So what you end up with is an architecture that looks like this, where as much of your view models and models is in the portable class library, and then you've got two different projects which implements some of the startup logic and the views for both your Windows Store app and for your Windows Phone app. You're also going to have platform functionality abstraction. So we'll talk a little about this. There's a lot of similarity between some of the things that happen in a Windows Store app and a Windows Phone app, but there are differences in implementation quite often. So you might, in the portable class library, express let's say, a navigation service as an interface, and then you plug in an actual platform-specific implementation of that navigation service from the Windows Store specific code, and that gets used and called from the portable class library objects, and similarly from the Windows Phone app. So we kind of there's a technique some of you may have heard of called dependency injection, which some of these techniques we can use for plugging in platform-specific functionality into this model. So let's have a look at portable class libraries. These are managed code. They are reusable libraries, and it's this one code base with no conditional compilation. So everything you code into this is compiled once, and the executable that comes out of that, the DLL, that is the compiled output of that, can be referenced directly from both a Windows Phone project and a Windows 8 project. So let's have a quick look at an example of that. So I've got my solution here. Let's just pin that, expand it out a bit. I've got two projects in here, reuse.Windows Phone 8, which is a UI layer for a Windows Phone 8 application, and I've got a reuse.Win8 here, which is a reuse layer for a Windows 8 application. So we can so you can see what this looks like. We can just run that one. Is that the startup project? Yes, it is. So it has no functionality in at the moment. It's just just a default empty UI project. Now we're going to add some functionality into this. So I'm going to add to my solution a new project, and I'm going to create a portable class library project, and I'm going to call it reuse.pcl. That's my name of my portable class library. And then when you say OK, you get this target frameworks thing up here. And you have to be a wee bit careful with this. Make sure you select the right ones. So I'm going to, well, we can uncheck them. But you see this drop down here. So you've got three choices: Windows Phone 7 and higher, Windows Phone 7.5 and higher, and Windows Phone 8. So there's obviously this is a technology you can use with lots of different code reuse scenarios. But the Windows Phone 7 one is very constrained, and if you choose that one, you find that you cannot do a lot of really pretty basic stuff in your class library. Stuff like iNotify property changed, and these things are very hard to implement. So your view models are almost impossible to implement if you leave it as Windows Phone 7. So Windows Phone 7.5 is OK. We're going to just go to the Windows Phone 8, so we're going to go for specifically a Windows Phone 8 here, and .NET for Windows Store apps. It actually says underneath you get an information. The following frameworks will be selected automatically, so we will also include .NET Framework 4.5 in there because that is compatible already with these two as well. So .NET Framework 4.5, Windows Phone 8 and .NET Windows Store apps are all good for this selection. So then we can create our portable class library. Here we go. And then we can start putting some functionality into it. So I'm going to rename this to Helper. And then I'm going to I'm going to make it a static. And we're going to put a simple little method in there, which is going to be public static int. And we're going to make this is going to be really high technology, this simple addition. How useful is this? And then that's going to add together two integers, value 1 and value 2, and then we're going to actually return value 1 plus value 2. How about that? This is going to be really going to change everything. So we can now just build our reuse.pcl project, build it. And that succeeded, not surprisingly. So we've now got our reuse.pcl project. I'm actually going to now open the folder, go and drill down, and just I'm going to copy the DLL just to make a point. I could reference this project, but I'm actually going to go down, and here's my reuse.pcl.dll. I can make a copy of that. And just to show that we can actually reference, you can create reusable libraries here. This could stay in the solution, but I want a reusable library I'm going to use across multiple other projects. So I'm going to go back up to reuse, and then I'm going to create myself a folder in here, a new folder called library. And drop the executable into here. So we've got a copy of that. So then we can actually sort of directly access it from these two different separate projects. So now let's go into the reuse.win8. I'm going to add a reference, and we're going to browse to a folder where we're working, which is down here. Add a reference, and it's okay with that. And of course do the same with our phone project. Same library, absolutely not a problem. So there we go, got a common DLL that is shared between the two UIs. And then of course we can start using that method in there. So let's do it in the Win8 project. Go into here, and just for interest's sake, we're just going to put a bit of code in here. So var sum is equal to helper. reuse.pcl.helper.simple-addition. Then we can put our two numbers, 2 and 4 or whatever. So there you are. You can see how we've easily added a reference to a portable class library from both of those solutions, even though they're not completely compatible. And this is all shared code. That's a very, very simple example, but really what you can actually implement quite a lot of your model and your view models in there. Okay, so that's a simple example of that. Let's go back to there. Code sharing techniques. So first, now a lot of the so once you're going to hit the buffers eventually with these portable class libraries, there's going to be stuff you need to do on both platforms that and you need to use there's a number of different approaches to sharing real actual physical code files. If you use add as link, you can include the same physical file in multiple projects. So if you make a change to it once, it changes everywhere. But that's not. You want to also have a technique of having variances between the two platforms, which is something you can't have hash if defs in a portable class library. So what to do where the platforms don't match? We're going to there's approaches are using hash if blocks, inheritance, and partial classes. So first of all, hash if defs. So by default, the new projects in Visual Studio, they create projects with a compilation constant already defined for Windows 8 apps of netfx_core, and on Windows Phone 8 it's Windows_phone. So we can take advantage of these. You could add your own, of course, but these are the ones that are in by default. You can make use of these when there are subtle differences in syntax. So here's an example of using a hash if block to allow us to change, because there is a bitmap image, I think, object which is in different namespaces in Windows Phone 8 as it is on Windows 8. So we can have a shared file that's referencing that and use hash ifs to change the namespace depending on which platform you're compiling it for. Here's another example. This is an example of how not to do it. It's a bad example. Because here it's kind of the downside of this is it can become a bit unreadable. So one approach here to make this easier to read would actually be to simply repeat the whole method signature within the two hash if def alternatives, rather than trying to split at the point of difference, which is just at that fourth parameter. Another technique you can use is inheritance. So you can have a shared functionality in a base class, that could even be in the portable class library, and then you can inherit from that base class and have platform specific differences in the different platform specific projects. So here's an example of which is taken from the solution, which is an album page view model, which inherits from something called which is the base class. That is where the comment functionality goes. And then you have a subclass, and we're using a naming convention of a Win album page view model, which inherits from that base class and adds additional methods. And we also have a Win Phone album page view model, which does the same thing for the Windows Phone platform. And this is another example here. Here the main page view model has been made abstract, so it has to be inherited from, and it cannot be instantiated independently. So this enforces the need for a platform-specific subclass to be created to override the abstract methods. And the result is what you see at the bottom there for the Windows 8, the Win main page view model.cs, and we have a similar one in the Windows Phone 8 solution. Another great technique is partial classes and methods. Partial classes came about back in the days of Windows Forms. Remember that, Rob? Where developers wanted to be able to add logic to a form but didn't want to modify the designer-generated code. So by putting their additional logic in a separate file and marking the classes as partial, you can split the implementation of a class across different physical code files. This has the added benefit in that only the code that is relevant to the specific platform is included in the project. So you get datasource.win8.cs wouldn't be included in the Windows Phone 8 project, for example, and vice versa. So here we see an example of that, the primary file, datasource.cs, with a method called retrieve folders that does a bunch of work before and after calling load folders. Load folders exist only in the platform-specific files. In this case, datasource.wp to .wp8. So if we just go back to the demo and go back to the original solution. And let's dig down a bit more deeply into this, the way this has been built. PhotoManager.shared, this is a portable class library. There's actually not very much in this example. This example application has been exaggerated to be able to demonstrate some of these other techniques. So if we go into photomanager.core.wp8, so this is a Windows Phone 8 specific part of it, which does some of the stuff that's specific to the Windows Phone 8 implementation. If we go to data.entities.picture.cs. You see this, here's this file. It actually, these are inherited from the portable class library, and it's got some properties in here, and it's, you'll notice that we've got a hash if on the top. So this file, picture.cs, is in both this project and in this project. But I don't know if you can see, you probably can't. There's a tiny little blue smudge on these, which indicates that the file has been added as link. It's the same physical file. If I try and open it, it says the document is opened by another project. So we've got one set of, but if I close it, notice, look at the top here. At the moment, we're in the Windows, I opened it in the Windows Phone 8 project, so this is the namespace that's being used. If I close it and then reopen the other version of it here, now it's in the Windows Phone 8 project, and of course, because netfx_core is defined for Windows Phone 8, I'll just show you the properties for that. Here you go, netfx core conditional compilation symbol in the Windows Phone 8, in the Windows 8 project, and in the Windows Phone 8 project, it's Silverlight and Windows Phone are the conditional compilation symbol. So this is how we can share code but have some subtle differences. Similarly, the inheritance, we can go to photomanager.core, let's see, let's find this thing, photo.win8 view models, shared album page view model. This is another shared file here. So this is the base class. So this is all this stuff is in the base class. And we've got, in both projects, we've got a Win album page view model in the Windows one, which inherits from album page view model. And in the Windows Phone 8 project, here we go, photomanager.core.winphone8 view model. Win Phone album page view model, that also inherits from the same base class, but we've got different overrides in it which are specific to the implementations on each platform. So these are some of the clever techniques you can use for sharing code and also introducing a few platform independent implementations. Okay. Something on architecture now. A lot of the APIs, the core BCL, are the same. So at the heart of things, we have pretty good news here. The core base class libraries are largely the same. The Windows Phone runtime is a subset of the full Windows WinRT, while the .NET libraries that sit alongside that, the .NET profile for Windows Store on Win8 and the .NET libraries for Windows Phone, have some commonality and some differences. But very good compatibility between the Windows.Storage APIs for the local folder stuff and access to hardware such as the sensors and accelerometer through the Windows.Devices API. So good commonality there. Differences are apparent at the interaction with the platform with launchers and choosers and the sharing and charms usage. These concepts and implementation are somewhat different, but with care we can abstract these differences away by introducing our own abstraction layer. So here's an example of identical APIs. So here we're using the accelerometer. This is where we get to leverage platform convergence. We can interact with the accelerometer on Windows Phone and Windows 8 in exactly the same way. So that's good news on that one. Not such good news, or it's subtly different, is the camera capture task, which is unique to Windows Phone. So actually this sample app doesn't have any photo capture in the Windows 8 app. You could implement it, but arguably photo capture from a slate is not as natural an operation to expect than from a phone app. So here again you're respecting the slightly different form factors and different usages. If you implement it on Windows 8, the APIs used are different. And then we've got near identical APIs. So file associations is almost the same. The actual XML that you need to put into the manifest is slightly different for Windows 8 than it is on Windows Phone. But the way in which it works, the URI mappers and all that stuff, is pretty much identically the same. So there's a lot of commonality in there. I won't. So I'll just skip over that one because we need to keep up on time here. So visualizing data. This is all about. We need to next area we look at is the architecture. Drill down a little bit more into this MVVM. This goes beyond just connecting our XAML elements to properties of our view model classes, but also to bind events to actions that execute in our view models. So it would be great if we could just create one app and it will run on both. But it's actually this approach is not going to be realistic for us. And is likely to result in failure. So when we're designing the information architecture for our application, we need to treat each platform as if they're in isolation. So we don't want to corrupt the design of the application on one platform with an existing design for a different platform. So we have to be pragmatic and develop the UX, the user experience for both, for each target platform, and then data bind down to as much common code underneath as possible. So model view, view model is the friend here, which essentially means, this is a gross simplification of using data binding. What we're going to do, just a quick refresher on this, we use XAML data binding to link the properties of our controls to the views of to properties of our view models, and UI controls get their display values automatically. So this was an example, we covered this yesterday, of a binding statement where the XAML in our presentation layer is bound to a property on the view model called line 3. And we have the different modes that we covered yesterday. One-time data binding, one way where it's synchronized to changes in the underlying view model, and two-way where changes in the UI are written back down into the view model underneath. And the magic that makes that work is this interface called iNotifyPropertyChanged. For a advanced MVVM, so just binding to properties actually for a lot of people is not quite enough. The view model needs to do more than simply manage data properties. It's got to actually handle actions as well. So when the user interacts with the UI and clicks a button or that sort of thing, we don't want anything, any logic must not be in our view. So that also needs to be executed out onto the view model. One technique you will see is this thing called commanding, where an event that fires in the view, instead of being handled directly in the code behind in the view, then it will instead is moved over and handled directly in the view model. And the technique we use for that is commanding. You can bind events. Here we got a button binding in the, see the command equals property. We're binding to a command handler called hello command in our underlying view model. So that's built into controls such as the button, but in Blend you can actually add these interactions on the phone to do that for other events. So this is the kind of code you'll see in your view model to actually execute the logic. In this simple example, we're executing a my hello command which sets welcome title property on the view model to you change the title. But obviously in a real application that would be much more sophisticated. Right, the last thing I just want to cover is where we've got subtly different things, which is navigation and visual states. So navigation between the two is essentially the same in that you navigate from one page to another, but there's implementation differences. So on Windows, you actually navigate, frame.navigate to type of main page. On Windows Phone, we call navigation service.navigate to a new URI. So you navigate to the main page.xaml. But essentially, it's doing the same thing, just in slightly different ways. So we can abstract away these differences, and we implement an iNavigation service, which is just a generic navigate to another place. And then we implement the implementation of this interface. We put one in Windows Phone code and one in the Windows 8 one. So the problem here is that view models want to call navigate and go back, which are actually things that happens in the presentation layer. But view models don't have any connection to that. So instead, we have this abstract way to a navigation service which handles that for us. And here's a simple example of an iNavigation service where we implement methods like navigate, can go back, and go back as a generic kind of navigation model. But then we implement it. iNavigation service is the interface which simply defines the signature of the methods we have to implement. But the implementation is different on the Windows 8 side than it is from the Windows Phone 8 side. And this is a good approach for having services like this that you can remove these differences and keep them from polluting your design. I'm going to skip that demo because we're really getting short of time on this one. So the code is available for you to download, so you can have a look at the implementation of that. Right, so in summary, Windows 8, Phone 8 and Windows 8 apps have a lot of commonality. Most of all, it's the design language, and they operate in quite similar ways. If you're developing for one platform, you're going to feel very comfortable with the application lifecycle of the apps on the other ones. Now, in general terms, and it's a gross simplification, you need to develop a different UI for each platform. But much of the rest of the logic can be shared, and portable class libraries are your friend here in developing as much as possible from exactly the same code and ending up with one executor, a DLL from that you can reference from both platforms. Other code can be shared by add as link, and you can handle the slight differences between the code and requirements of both platforms using things such as compile time constants, inheritance, and partial classes. That's it. It's difficult to... Oh, here we go.
Andy,
what's this?
how would you do the cross-platform UI with this Cassiopeia? Is that possible?
Major surgery would be required, I think, Rob.
I think we were the innovators with Stylus Touch.
Yeah.
It's coming back, isn't it?
Yeah, absolutely.
Leading
Yes.
the way.
Yeah, well, that would definitely need its own UI layer, that's for sure.
Absolutely.
Yeah. All right. Well, thanks for your attention. That's me done on this. We've got just one session left. One more session. And so I'm going to give way now, and
we'll have a special guest.
We have a special guest, and Rob is going to take you through some stuff of web development for Windows Phone 8.
That's crazy talk.
All right. Thanks very much.
See you in a bit.